So another way we represent parts of a whole is using decimals. So again, first about what a decimal is, let's take a look at these examples. 1.48. This might not necessarily be exactly equal to 1.48. What we really think is if this is really 1.48, decimals have an infinite number of numbers behind them. So it would be 1.48, 0, how we indicate that that's going to continue on forever would be putting a line over this. This one, 1.260458. Again, we don't really know what this is, right? This is there might be more numbers back here that the indicated. So like and let me pull up a calculator real quick and show you. Most people, let's say I am working on this and I have, I don't know, 127 of something out of a total of 186. We get this, right? Now, does the number really stop at the 5? The answer is no, but our calculator ran out of places to provide to us. So this is not the true value. There is error to this number because even if I write this whole thing out, there's other things there, right? And this is the problem with decimals. Last one to take a look at. We have 1.781 4652403542035 42035 42035. It looks like this is going to keep repeating. So 1.781 465 42035. This is what's repeating forever. So if we were going to write the exact version of this, this is what it would be. And again, nobody writes it like this. So the issue with decimals is it's not the whole thing. We don't know what the whole is. We don't know what the part is. So when we look at a number like this, we saw this on the homework a couple weeks ago. 0.5 is it really equal to 1/2? Well, I don't think so. 0.5 there might have been other numbers, and it might have been something like 0.50000321885. So it's not exactly equal to 1/2. We're going to say that it's approximately 1/2. I want to extend this to what we talked about last week, which is 1.4 times 10 to the third equal to 1400? Well, 1.4 times 10 to the third, if we convert that out of the scientific notation, yes, it would look like this, but we don't know. Maybe it was something like maybe it was 1,402, and the person said, okay, we're just going to actually just turn this into scientific notation instead of 1.402 times 10 to the third. All right, let's not do that. Let's just get rid of this, and let's just write it as 1.4 times 10 to the third, and then that just looks nicer to us. So 1.4 times 10 to the third may not exactly equal to 1400. When it's in this decimal format, say 1.4 times 10 to the third is, and then we use this symbol to say it's approximately equal to 1400. It's close. We're not really sure because, again, they could have rounded those things for us to get there.